Hello there, Mr. Sutton here, bringing you the Algebra 2 5-1 lesson on nth roots and rational exponents. If you're doing the honors version, this is going to be all in one shot. For the CP non-honors, we'll be splitting this into two parts. Here's what we're going over. We're going to be finding nth roots of numbers with and without a calculator. We're going to be evaluating expressions that have rational exponents, again with and without a calculator. And we'll be solving some equations using this idea of nth roots. The first thing we're going to take a look at here is these two problems. They want us to find the indicated real nth root. In the first case we have cube root or third root. Over here we have fourth root. They want us to find both of these and include any negatives if that applies. So in general, this idea of nth roots, the nth root of a number b is just the number I need to raise to the nth power to get b. So for example here we're asking, what do I need to raise to the third power, and this is called the index by the way, what do I need to raise to the third power to get negative 216? So pause the video and see if you can make sense of these two problems. Try it without a calculator. Alright, so to get negative 216, well I know that if I do 6 to the third power that's positive 216. So negative 6 to the third power would give me negative 216. So negative 6 is the cube root of negative 216. Now over here, we're asking what do I need to raise to the fourth power to get 81? And if we do 3 to the fourth power, 3 times 3 times 3 times 3 is 81. So we could write 3 here. But now, if we did negative 3 and multiplied 4 of those together, that would also give us 81. They said to include negatives if applicable, and it applies here. So our answer for this one should actually be plus or minus 3, because both of those work to give you 81. Now normally, for expressions like this, we would normally just take the positive root, and that's what the fourth root of 81 actually means, is the positive. But they said to include negatives, and we'll need to include them later on anyway, so it's good practice. For our next trick here, let's talk about rational exponents, so fractions inside exponent land. What does this 16 to the 3/2 actually mean? So when you have an exponent that is a fraction, like a to the m divided by n, this means one of two things, and these both are equivalent. So this could mean a to the nth root, and then all of that raised to the m power. Or you could do things a little backwards, and you could think of this as a to the m with the nth root of all that. But the basic idea is that one way or another, the numerator in your fraction is going to be the actual power, if you think of it that way, and the denominator in this fraction in the exponent is going to be the index of the root. So we have power over root, and a way that you could remember that is that the roots are underneath the trees and the power is up top, I guess. Something like that. So with that in mind, a good way to do these sorts of problems if you don't have a calculator is to convert it into one of these two forms, and it's your choice which one you want to do, and then go from there. So pause the video and try out 16 to the 3/2. Alright, so I'm going to rewrite this as the second or square root of 16 raised to the third power. And square root is really just an index of 2. It's just an invisible 2 that we don't write because it's a very common root. So you can do the power and the root in whichever order you like. The way I've written it here, it lets me do the root first. So this is going to be the square root of 16, which is 4. And then 4 to the third power is going to give me 64. Even though you have the choice, I do recommend doing the root first because then you're raising a smaller number usually to an exponent. Doing the exponent first, doing like 16 to the third, I don't even know what that is, and that's going to give me some big number that I'm going to have to figure out the square root of, so this way works a little easier for me. Now moving on to our next problem here, we have another fractional exponent, so we'll have to deal with that about the same way we dealt with this one. We also have a negative exponent. And if you don't remember what these negative exponents are, just a little reminder here. If you have a to the negative n, that negative exponent is basically giving you a reciprocal. So you can write this as 1 over a to the positive n power, Or another way of thinking about this is you could call this 1 over a raised to the n power. So that exponent could go right here after taking the reciprocal of your base, or you could move that entire base downstairs with a positive exponent. Either way. So pause the video and try out this next one. All right, so I'm going to do this in 2 steps. First step, I'm going to take care of this negative exponent by moving the 32 downstairs and giving it a positive 3/5. For my next step, I'm going to convert this into this radical form that's easier to do if I don't have a calculator available. So this is going to be the 5th root of 32 raised to the 3rd power. Let's see, what do I need to raise to the 5th power to get 32? Well, that would be 2. Knowing your powers of 2s, 3s, and 4s, and 5s and 6s is pretty helpful in this situation. So this is going to be 1 over 2 to the 3rd. And then 2 to the 3rd is 8, so this is 1 over 8. Now that we've talked about finding roots and rational exponent expressions without a calculator, let's actually let you go back and use the calculator. So pause the video and see if you can do 12 to the 3/8 power. All right, let's see how that worked out. So here on my Desmos scientific calculator, I'm just going to do 12, press my exponent button, wherever that is. This looks like a good one, or you could do Shift 6 for that little hat symbol, and then I'll just do 3 divided by 8 right in the exponent. So 3 divided by 8, it automatically does it for me. And that comes out to, they said 2 decimals, so 2.54. Okay, we're going to do another one on the calculator, this time a radical one. Now you've got a few options for how you could do this. One option is you actually could convert this back into a fractional exponent and just run it on the calculator that way. And that's perfectly fine to do. But I want to give us a little practice using some of these roots as well, because those look sort of cool. So here's some good ones to know on Desmos. Desmos has 3 different root sort of function words that automatically turn into one of our lovely radical symbols. If you just want a square root, SQRT will give that to you. If you want specifically a cube root, that would be CBRT. So those are kind of the 2 most common. And if you need any other kind of root, or you just want to do one of these 2 just more generically, you can type in nth root, and this time they actually spell the word root out. And that will give you a radical with an index that you can fill in with whatever number you want, even decimals if you wanted to. So pause the video and pick a way of doing it and try this one out. All right, so let me show you on Desmos a couple ways you could do it. As we mentioned, you could convert this into a fractional exponent. So we could call this 7 exponent, and then it would be the 3rd power over the 4th root, so 3 over 4. And that comes out to about 4.30. Another way of doing it is with the root. So let's see, let me open a parentheses, and I'll do nth root in here. And then I'm going to do 4th root of 7. And let me close my parentheses now. And I'll raise that to the 3rd power. And that again gives us 4.30. So if you are doing the honors version of this lesson, then we're going to keep going and talk about solving equations with some of these nth roots. If you're doing the CP non-honors version, then this is actually the end of part 1 for you. You can pause the video, do some practice problems on all this kind of stuff, and then come back, rejoin us for solving equations. So here we are, solving some equations using nth roots, whether you're continuing on from the honors or just rejoining us from the CP. So the idea here is, again, we're trying to solve this equation. A couple steps that we're going to take, just like we did when this was just an x squared and not an x to the 5th. And that is that we want to isolate that exponential part of this, the x to the whatever. And then to undo the 5th power, in general, to undo the nth power, we just need to use an nth root, just like we use a square root to undo a square. So in general, we want to isolate x to the n, whatever n is, and use the nth root. Pause the video and see if you can do that with this expression, this equation. All right, so Going through this here, first thing I need to do is get the x to the fifth by itself. I can do that by dividing both sides by 4. 128 divided by 4, I'm just doing this in my head, that is 32. And now to undo the fifth power, we're going to need the fifth root. So we'll write x equals the fifth root of 32. And we actually already kind of saw this earlier. That's the number I have to raise to the fifth power to get 32, and that is 2. For our next problem, we've got x minus 3 to the fourth equals 21. So we've done these sorts of problems before when this was a square, a 2 here instead of a 4. We're going to approach it in more or less the same way. Just a reminder from when we were solving quadratics that were like this, and that is that when you use a square root, when you use a fourth root, when you use any even root to solve an equation, you need a plus or minus when using an even root. So this is, again, 2, 4, 6, 8, any even root, you have a positive and negative, because you can take an even number of negatives, multiply them together, and it will give you back a positive. That's the reason we need to include the negative. So pause the video with this in mind and see if you can come up with however many answers we should get for this problem. All right, so first step, we're going to take the fourth root of both sides, because we already have the something to the fourth isolated here. So we can write x minus 3 equals, and because it's an even root, we need to write plus or minus fourth root of 21. For our next step, we're going to add 3 to the other side. So we have 3 plus or minus fourth root of 21. And then we're actually going to come up with two answers. If they didn't ask for 2 decimal places, we could actually leave it like this because it cannot be simplified further. There is no whole number fourth root of 21, but since we can use the calculator, let's figure out what this should be. So we've got 2 roots. We have 3 minus the fourth root of 21. Now to get fourth root, I need to use nth root again, that notation. We'll do a 4. We'll do a 21 in here, and that comes out to about 0.86 if I round that off. And then let me go back and just see what happens if I do plus instead of minus that root. Easy to just change that to a plus, and that gives us about 5.14. For our final boss battle question here, we're going to do one more involving some fractional exponents, as you can see in the formula here, and we're going to throw a little real-life sort of thing in there. So let's say we have a hospital purchasing an ultrasound machine like one of these for $50,000. I'll bet it actually costs more at this point, but whatever. The hospital expects the useful life of the machine to be 10 years, at which time the value will have depreciated to $8,000. So these are some key numbers we're going to want to keep in mind. $50,000, $8,000, 10 years. The hospital uses the declining balances method for depreciation, whatever that means. So the annual depreciation rate, R, in decimal form, is given by this formula down here. And then in the formula, N is the useful life of the item in years. S is our salvage value. That's what it becomes worth after it's been depreciated. And C is the original cost in dollars. Based on this, they want to know the annual depreciation rate the hospital is using here. So pause the video, see if you can use this formula, and figure out that depreciation rate. All right, so this problem is really just kind of you have to know where to plug things in and use the calculator. So let me just write 1 minus and then set up sort of a skeleton for me to plug things in here. So our salvage value, again, that's what we depreciated to. That was this 8,000 figure they gave us. And C, that was the original cost. That was the 50,000 we purchased that ultrasound machine for originally. And then we need an N for this exponent here. That was the useful life, they said. And they, let's see here. N is the useful life. The useful life is 10 years. So we'll do 1 over 10 for that exponent. And at this point, we just need to carefully plug this into our calculator. So here's a Desmos. Let's do it. We've got 1 minus, and then let me open a parentheses and do a fraction. We've got 8,000, 50,000. Close that parentheses, exponent button, and we'll do 1 divided by 10. and that comes out to about 0.167 and some change. So that's the decimal version of the depreciation rate. If you want to make that a percentage, you can move that decimal over to get 16.7%. So that's it for this one. Hopefully the knowledge you have gained from this lesson will not depreciate too much over time. Till next time, Mr. Sutton signing off.